Hello, everybody. This is Beshoy Riad, PhD candidate at Missouri University of Science and Technology. And my poster title today is Implementing the Lightweight Deflectometer for Missouri DOT Construction Acceptance of Unbound Material Layers, a project which is funded by Missouri DOT. So the background of this project that currently most DOTs are still using the density-based methods for convection quality assurance by means of NDG. A photo of the NDG is shown here at the bottom left side. NDG testing becomes less desirable because of safety, regulatory, and cost concerns. Density is not directly linked to the pavement performance. In the meantime, modulus-based convection quality assurance is gaining attention within the pavement industry as modulus is a fundamental input to the pavement design. In the last decade, several devices were proposed for modulus determination in the field. Some of these devices are shown here on the bottom right-hand side, particularly the lightweight deflectometer, which is the focus of this project. The lightweight deflectometer showed promising results among these devices and has been employed by few DOTs and other countries. So the problem statement that all the existing lightweight deflectometer standards use the control strip method to determine the field target field value. The control strip method requires the construction of large areas in the field, which is hard to be achieved in all projects, particularly small projects. Missouri DOT is actually interested in replacing the NDG with a lightweight deflectometer, and the MoDOT recently participated in a pool-funded project with Maryland DOT, in which the lightweight deflectometer test on convection mold was used to determine the target field value instead of the control strip. More research is needed to evaluate the performance of lightweight deflectometers, and the lightweight deflectometers are actually needs to be accompanied by a field moisture content determination device, which is not available. So the objectives of this poster today are to introduce the background of this project, present the comprehensive field testing program conducted on two types of soils, and show the most significant factors affects the lightweight deflectometer results in the field. So for field testing, the purposes of this task are to evaluate the application of the lightweight deflectometer and selected field moisture content measurement devices for typical Missouri soils in actual construction practice, and to correlate the field lightweight deflectometer with the laboratory results. Two field testing campaigns were conducted on the I-270 North project in St. Louis, Missouri. So we tested actually two types of soils, the SUB sand, which is used as backfill for the MSE walls, and the lean clay, which is used as an embankment for the embankment construction. We did lightweight deflectometer testing right after convection and after 2 hours from convection to check the effect of evaporation. So for every construction site, we did lightweight deflectometer testing, NDG testing, and moisture content measurements by means of the Ohio's MB 120 moisture analyzer and the agrimeter moisture detector. For the first site, which is consisted of SUB sand, we had a section that is 17.4 meter by 5.6 meters, and there was MSE wall under construction on the right-hand side of the testing section, and also the convection and the grading started from the bottom to the top. So as you can see here, we have contour lines on the left-hand side for the moisture content changes. The minimum moisture content value was 5% and the maximum was 8%. And for the modulus changes, the minimum value was 14 megapascal and the maximum value was 38 megapascal. As you can see here, for the moisture content, it was increasing from the bottom to the top. I believe this was related to the evaporation because they started grading and convection from the bottom to the top. So it was increasing from 5.2 to 8%. And for the lightweight deflectometer modulus, as you can see here, the minimum value of modulus was near the MSE wall due to low confinement. This is obviously shows the effect of adjacent structures on the modulus values. We also did testing on lean clay in another site. So as you can see here, they used sheepfoot compactor to compact the lean clay. So it was unleveled. So before testing, we leveled the surface, and then we did lightweight deflectometer testing, agrimeter, and Ohio's Testing for moisture content. So the left-hand side contour shows the moisture content changes, which is from 14, the minimum is 14% and the maximum is 20% for clay. And for the lightweight deflectometer changes, we had from 2 megapascal to 18 megapascal. As you can see, for the zones that has the highest moisture content, it has the lowest modulus value, and for other zones, the orange zones that has the lowest moisture content, or it is the driest conditions, it shows the highest modulus values, which is shows the effect of moisture content on the modulus, on the lightweight deflectometer modulus. As we mentioned, we also did testing right after convection and 2 hours after convection to check the effect of evaporation. As you can see here on the left hand side plot for lean clay, there wasn't any change in moisture content or modulus after 2 hours. But for SGB sand, we noticed a 10% decrease in the moisture content and 10% in general increase in the lightweight deflectometer modulus due to the effect of evaporation. So here we come to the conclusions. Literature review shows that most of DOTs are still using the density-based methods by means of NTG. Modulus-based quality assurance is gaining attention within the pavement industry. The lightweight deflectometer showed promising results and has been employed by several DOTs. Field test results showed that the lightweight deflectometer modulus is sensitive to moisture content changes, especially for fine-grained soils such as the lean clay. And the lightweight deflectometer results can be significantly affected by adjacent structures, especially that causes decreases the confinement, such as mechanically stabilized earth walls, such as our case here. And after 2 hours of convection, 10% increase in modulus was noticed for SGB sand and no change for lean clay. Thank you very much for your time.